Right, for this questions, part A, first look at data. It lies between pi and 3 pi over 2. Immediately we know that it's in the third quadrant. So perhaps you want to help yourself with this diagram. A triangle like this, perhaps, and then call this data. And it's because given that cosine theta is a negative 3 or 5, so we know that here would be 3 and the hypotenuse would be 5. Don't have to put negative sign here. And so also immediately you able to write down values of sine theta, which is of course here the opposite of the data is 4. By Pythagoras you can calculate value of that side. And so this is clearly 4 over 5, but negative because the third quadrant, and tangent data would be 4 over 3, right? And how about part B here? Let's give it a go here. Then sine theta is equal to 1 over 5, and theta lies between negative pi over 2 and pi over 2. And that means that for theta it is somewhere between here and here. But since sine theta is positive, positive 1 over 5, now this implies that it must lie therefore in this quadrant 1. So now we can draw this, and the triangle again. The data should be helpful, and this is 1 over 5, and using Pythagoras the length of this side here can be calculated, and that would be actually 24, or rather square 24, and you can simplify this further as 2 over square root of 6. Okay, 6 right here, and therefore your cosine theta, you can then get your cosine theta as 2 square root of 6 over 5, positive because in the first quadrant. We don't need the value of tangent theta here. You will see soon see why that is the case. Using identity for sine 2 theta and cosine theta, and substituting the value of 1 over 5, and also for cosine theta would be 2 square root of 6 over 5, and then you have this 4 square root of 6 over 25. Similarly, you can actually, and then continue here, let me cosine 2 theta, you can use either of the identities. Here I think I choose this one, 2 sine square theta, and sine square is 1 over 5 sine theta, I mean, and finally you get 23 over 25. See, pretty simple.